Hi, my name is Alex O'Neill, and I'm here to show you my 15112 term project TerraMotus. TerraMotus aims to bring real-world interactivity into physics simulation on a computer. Before we get into the nitty-gritty of the computer program, let's go check out the hardware. So here we have a sandbox filled with about 100 pounds of sand. Suspended over top is the Kinect, getting a top-down view of the sand in order to generate a height map, which is then imported into the program. The goal is to have the user make any arbitrary patterns, shapes, structures within the sandbox, and then let their creation roam free on the computer. Okay, let's get to the simulation. And here we are. So I'll run the program. Give it a minute to load. And here we are. So the main screen has three menus. The first one is the About menu. The About menu tells you essentially about the program and the basic controls. You can read that later in your own time. Now there's two other menus. The first menu is the Play menu. We'll go over that one. Then we'll come back to Browse. When you hit Play, if it scans and detects a Kinect connected to your computer, it will allow you to use the Kinect as an input option. Otherwise, you'll have the option of using CSV files. So for now, let's check out the CSV files. Unfortunately, there aren't any on this computer, so it's going to show a blank screen. Now, if we go back into the inputs, we select the Kinect, we're going to be given a loading screen. Now, in the background, it's taking the Kinect data and it's filtering it to remove many of the errors that the Kinect actually gives back. So ideally the Kinect would give a perfect representation of what it's scanning, but often there are chunks of data which are missing because of reflectivity or issues with the Kinect sensor itself. So right here, what's happening in the background, actually on a different core on the computer, is it's taking the data and it's filtering out those issues and guessing what should be there instead. Since this is slowed down now, we'll be entering simulation any second. Sorry about that. Okay, so here we are in the simulation. The user is given a car to drive around. They can explore what they've created using the commands outlined in the About file. And as you can see, we are truly navigating what was in the bed of the sandbox. As you can see, there's the crater I made in the center. Over there, you can see some of the little divots. And yeah, so, I mean, the possibilities here are endless. You can make whatever environment you want. I made a racetrack in the past. You can make crazy jumps to go off of. Anything's really possible. A few features I'd like to point out are the Kinect data gives back around 300,000 data points, and this is drawing about 2 triangles per data point. So it's around 600,000 triangles that are being drawn every frame. This is working efficiently because I used a method in OpenGL to push drawing of graphics to the graphics card. So this is actually an incredibly efficient way to draw this many triangles. And in previous versions of my program, I wasn't really optimizing for that, and it had trouble keeping up with under 100 triangles. Okay, so here we are in simulation. There are a few buttons at the bottom here which are important. The first one is the home button. If we click on that, obviously we go back to the front page. But now if we click play again, there's another option here. This option means that in case you hit the home button on accident or you're just looking at different parts of the program, when you come back to this menu and you click this button, it'll send you right back into simulation where you left off. And you can go play some more or do whatever you do. The other button is a pause button, which just pauses the simulation. And you can rotate around the car within the pause, so you could make your own cinematic movie. Anyways, we'll go back to play. And now finally, this last button. So within this program is an integrated client and server. The server runs on a different computer at my house in Minnesota. But right here, when you're ready, all you have to do is you have to hit this button. It does a little animation if you notice there. And once it's successfully uploaded this file to the server, other people can then go and download it, either from the server itself or through an in-game menu, which I'll show through the Browse option. And let's go see if that uploaded. So let's pause this. Let's go over to Chrome. Here is my website. So this is running on a fast CGI implementation in Python. It's running on top of Apache 2. Here are some previous examples of Kinect scan data. This is just for stuff around the room. That's my shoe. Here's the racetrack I was talking about earlier. And now if we refresh the page, at the very bottom we'll see the most recent map we uploaded. So there again, there's a swirl, there's the divots and everything. The end here is a Unix timestamp, so you can differentiate between which file you want to download. Right here is a download button, which would just download the CSV file right to your downloads folder, wherever that's located on your computer. So yeah, this is a good way just to look at uploaded files and maps that users have created. So now, if we go back to the simulation, we can play it. If we go to Home, now this is what the Browse menu is about. If we click on Browse, it'll give you the different maps that are on the server. Now, we can select any of these maps and it'll download it, and then we can get launched right into the game. So I personally want to play with the giant spoon I scanned, so let's select that one. Right now it's pulling down the data from the server. I used to have this implemented actually in 2 languages, but I streamlined it into 1 and it works way better now. So yeah, we'll just wait now and we'll get the file, and then once the loading bar starts to slow down a bit, that means it's entering simulation. Perfect. So here we are in simulation. As you can see, this is the map we downloaded from the server. So we can go and check out the spoon that's on the ground over here. We'll just turn the car. And yeah, there we are. So as you can see, there's the spoon right there. It's the exact same map that just got downloaded from the server. It does take some time, depending upon the internet connection, to download the server, or to download the map. However, once you get the map, it's not too hard to actually bring it into the physics simulation. And that's it. Thank you for watching my video. I hope you enjoy the program. It's also on GitHub, actually. I'll also have a link at the end of this video showing where to go, where you can see all the source code, all my revisions, everything that goes in behind it. And yeah, so thank you.